Hello, this is Data Driven and I am Ibtida bin Ahmed. So, our final score came from two findings. Neither of them was model, and I'll show you both. The two facts are here, like 76,020 accounts, 350 anonymized features. Among them, 3.96% was at risk. So, one account out of 25 accounts are at risk. So, here we used F1 as a score metric, and the submissions were cut at 0.5. So, the metric is the decision problem here, because here's the first one. If you submit the probabilities, the leaderboard cuts them at 0.5. On a 4% problem, a properly calibrated model almost never emits a probability that high. And in our out of full predictions, 24 rows out of 76,020 clear 0.5. So the highest probability anywhere is 0.86. And so you flag almost nobody, and F1 collapses to 0.003, which we can see in this graph. F1 collapses at 0.003, where platform default is p greater than or equal to 0.5. So in the next section, we can see that the standard cleaning, we are doing some cleaning here. The 28 constant columns and 14 exact duplicates we have found there. The pairs with R's absolute value of 1 is counted at 35, and greater than 0.95 is counted at 122. So after the cleaning, we hit a problem. Our cross validation said AUC 0.896. The leaderboard behaved like 0.78. The gap is too large to be noise. So we went on looking what's going on out there. So duplicate rows between the train and test, we got none. In near duplicate clusters inside train, we also got nothing. And in oversampled positives, we also got nothing. So in the covariant shift, we got the most important thing. In the covariant shift, we saw that in the par feature adversarial AUC test, we got the result of 0.504. So it was a coin flip moment for us. And if we go to the second finding, that the 27 columns are also structurally inconsistent. Real account features are counts and balances over the same customers and the same products. So every genuine column is like strongly correlated with at least one sibling column. And the median is not 0.98. There is 0.98 we can see here. And the 27 flagged was 0.02. So we dropped them. And the CV fail and the leaderboard rose. So we can see that from the red line and from the blue line that the CV AUC, it got 0.896 to 0.836. It fell down from 0.896 to 0.836, and the leaderboard F1, it rose from 0.233 to 287, which is showed in red line here. The two moved in opposite directions, and the model is something like deliberately unremarkable. Decision trees, random forests, XGBoosts, light GBM, neural networks. The serious candidates span about 0.01 AUC. Model choice was never the bottleneck there. So we ended with 24 models over random subspaces. We tried 11 approaches, but we didn't get any kind of remarkable gain. We tried the target encoding, the 6 categorical skulls. We tried principal component analysis and k-means featuring. We did Optuna 120 trials, but it was also went in vain. It also went in vain. We tried ensemble modeling. We tried 2 stage confident cascading. They didn't help much. From understanding the data, the value of our score went from 0.178 to 287. So the stages were something like probabilities when submitted. It gave us CV AUC 0.896, and the operating point also tuned that 0.896, but the LB F1 leaderboard F1 score was not increasing. But when inconsistent columns were removed, the score from the leaderboard went very high, and it went to 0.287. It was a 61% improvement from the understanding the data rather than the tuning models. We can see this in our graph here. So we'll have to bring a closure to this, and we'll have to show the code right now. So going to the code, we get that what we first did is the configuration. We did the configurations, and also the trials. N trials is 60 and ensemble was 40. We gave a seed at 42. We did the path resolution here, and what we did here is some cleaning, because cleaning the data, we showed that we got excellent results from that. And the isolation rule, the single most important step, was here. Well, what we did, we dropped some columns, and we dropped some duplicates and some leaky columns. And after that, the column identity mapping was done here. We got some aliases for 5250 with var38. One thing I need to mention, that as our input, we also used a public dataset, which is Santander CS. That is the Santander customer satisfaction problem. We brought it here, and we used it, and we made connection using the aliases. And after that, we did some feature engineering and the hyperparameter searching, which was worth noting because it rose our scores in the leaderboard F1 much higher. And the runtime budget check was also done here, so that it doesn't exceed our quota. Surprisingly, it was really fast, and we didn't have to worry about that. We ran the search, and we bagged the ensemble modeling. That is, we thought about AdaBoost, we thought about XGBoost, and a lot of things, but what worked here is bagged ensemble modeling. We did it here, and after that, we got the rank averaging in our cell 12. The ensemble OF AUC gave us some promising results, and after that, we went to the summation and created a summation and submitted it. Thank you very much for your time and patience.